Hello there, geometry peeps. Welcome to the introduction of proofs. Now, pretty much we're going to do three things tonight. And those three things we really need to know in order to get to the bigger picture of things. So I like to call this not only intro to proofs, but kind of mini proofs. Okay, and these mini proofs are vital to our success moving forward. So the first one is given B is a midpoint of AC. So when we're attempting to do proofs, they're always going to give us some information. That given information is really important because we need to use that information to solve. So we're saying B is a midpoint of AC. So if I have AC, B is the midpoint. Now what does that mean to us? Well, to us we know if a midpoint cuts a segment in half. So we know that those two pieces are equal. Now we know that, me and you know that because we've been taught that, but you kind of have to envision talking to a third grader, all right? And you have to explain this to them in this format. So this is called a two-column proof, statements and reasons. Okay, and the first thing we always do is we're going to state the given statement. So I'm going to state B is the midpoint of AC. And we know my reason is, well, that information was given to us. Somebody told us that information. Okay? Now, that's kind of our premise. Now we have to draw a conclusion. Well, we said our conclusion is B is exactly in the middle. So then I can conclude that segment AB is congruent to segment BC. Now, my reason is, well, because we know a midpoint cuts a segment into two congruent pieces. So if it is a midpoint, then it cuts a segment into two congruent pieces, or let's say two congruent segments. My eraser doesn't want to work. Two congruent segments. Okay, so when given a midpoint, that's how we got to explain it. The first piece of information is given, and then the second piece of information we use a conditional statement to explain it. So if it is a midpoint, then it cuts a segment into two congruent segments. So what we've done is provided a reason for our conclusion. Alright, so this is kind of like our hypothesis, our first statement, and our second statement is our conclusion. Alright, so that's how we handle midpoint, and we've proved something congruent, so we've used that given. Okay, let's go to the next one. Now, in this one, I'm going to call this angle 1 and this angle 2. And all it says is given the diagram. So all we're given the diagram. So if you were to look at that diagram, what would you conclude? Well, we would conclude that angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. Now, my reason here is because we have vertical angles, and vertical angles are always congruent. Alright, so we're just going to say that. If vertical angles then the angles are congruent. Okay, because we can always assume vertical angles and we can assume straight lines from diagrams. In geometry, that's what we can assume. So we've proved something congruent, so we use in this given piece of information. Alright, so now for the fun one. Now, perpendiculars. So given AB is perpendicular to CD. So let's call this segment AB and this segment CD. So we have AB and CD. Now, I'm going to make a point here, and it'll make a little more sense later, but I'm going to say whenever you have a perpendicular, it takes 3 steps to prove something congruent. If you notice in our midpoint example, it only took 2 steps to prove them congruent. In vertical angles, it only took 1 step. But with perpendiculars, it takes 3 steps. So the first statement is always our given. So we have AB is perpendicular to CD. That's given. That information was provided for me. Okay, now, what does it mean to be perpendicular? We got to ask ourselves, what does it mean to be perpendicular? And right away, we should know that if it's perpendicular, we know we have 90-degree angles. They cross at 90-degree angles. Alright, so we're going to say that. We're going to say angle ABC and angle ABD are right angles. Are right angles. Okay, now the reason for that, well, we know we have perpendicular lines. So if perpendicular lines, or let's say it like this, perpendicular lines create right angles. Right? Perpendicular lines create right angles. All right, and we know that for a fact. That's the definition of perpendicular line. Now, so we stated what a perpendicular line does. We stated that it makes right angles. Now that we know they're both right angles, we can state that they are congruent. So I can say triangle ABC is congruent to angle ABD. Now my reason is, well, we know all right angles are congruent. Okay? If both of them are 90, then both of them have to be congruent. Alright, so again, perpendiculars take 3 steps. First, you got to say they're right angles. Secondly, we can say they're congruent. Again, you have to, when you're doing these little proofs, you have to pretend like you're talking to somebody who knows nothing about geometry. So by saying they're right angles, and then by saying, well, all right angles are the same, you've now made sense of yourself. We've proved something congruent, we've used the given, and we out.